This is Suman and welcome to my presentation of final assignment for managing machine learning project. So the topics that we are going to capture today is evaluating the opportunity, understanding the business problem through crisp DM method, validating the plan for solution, key ML system design decisions, and potential threats in production. And finally, we'll conclude. Opportunity that we are going to evaluate is a AI-backed tour and travel planner. We need to identify the pain points in current process and potential areas for improvement. We'll further determine the feasibility of applying AI ML in this process. So let's understand the business problem crisp DM way. Let's define the problem. Our target users are the individuals and tour operators who are in tourism and hospitality industry or are looking to for a travel or a trip in the upcoming days. The problem is that we need a smarter and easier way to plan end-to-end holidays. Why it matters? Because an unplanned or badly planned holidays lead to a distasteful experience and a mediocre memories. Current state is that individuals rely mostly on the travel websites, tour operators, and self-research to plan their leisure time, which can be improvised a lot using AI-powered tools. What would be our success? Improved experience, beautiful memories, and a satisfied customer experience. Metrics are good feedback, higher signups, and higher ratings. Outcomes will be mostly MSC of the bad experience. Reduction of itinerary creation time from weeks or days to minutes will be our target. And output here also will be the reduction of mean square error of bad experiences by the travelers. Few of the constraints that we foresee is the creation of travel plans will be instantaneous after input of variables and filters and complying with the travel regulations. Some of the factors that will help us in identifying and creation of the plan is time duration, whether it could if the travel plan is of days, weeks, or months. The pack size. Is it a solo travel? Is it a family travel? Small group tour or big group tour? So the number of people can start from one to n number of travelers. Destination, it could be a single destination or multiple destination. It could be domestic or international. Experience, the kind of travel that the particular individual is planning for. It could be a budget travel, premium travel, or lavish travel. So depending on that, accommodations will be given. Nature of tour could be sightseeing, commercial, adventurous, and religious. Now let's move into the validation plan for the solution. Now data should be divided into multiple parts for this. Training data set should be 70%, validation data set should be 10%, and test data set should be 20% of the entire data that we have in our disposal. Training data sets should have properly defined features and labels should be fed into model for outputs. Data collection and cleaning. The data should be collected intensively from every source possible, be it tourism website data, government data, external data, weather and municipality data. Data updates should happen continuously and should be automated. Defining performance metrics. Accuracy should be more than 99% correlation from the customer expectation. Signups will help us to define whether the customer is liking it or not. Solutions will be up to date with travel regulations and establishing baseline and validation. Initial performance will match with the current solutions that is available in the market. We should put new benchmark for the output and apply k-fold cross validation for the results. Manual evaluation of results from time to time will help stay in the correct direction. EML system design decisions. There are several system design decisions which impact the choice of technology we use in our machine learning system. Our travel assist ML system should have a cloud-based system so that the itinerary computations can be done online on cloud and results to be delivered on the end-to-end devices. We don't need a very high computing system because most of the work is getting done somewhere else on the servers. A stable network connectivity will be required to get the real-time update on the travel queries like flight prices, hotel availability, and experiential booking. High throughput generally because of the large number of queries and quicker turnaround expectation. Prediction, batch prediction, but online backed. Future is that we should have a hybrid model in place to accommodate common responses for a common queries as the regulation doesn't change very often and the mixture of online for real-time pricing of travel related bookings. TML system design experiences. Now, the second part is that the ML technology selection is another important decision while creating a ML-backed prediction system. Cost versus time is a suitable approach for technology selection. Open source ML libraries and commercial ML libraries are available and are most commonly used. Auto ML becomes very expensive, and the building ML system from the scratch becomes very time-taking and complex. So, decision is that we'll have to select a programming language, be it Python, R, or C++, whereas a Python is the most commonly and used. Data processing toolsets could be Python for our ML-based travel planner. Modeling toolsets could be Archie, ER Studio, Erwin Data Modeler, or similar such tools available in the market. API interface, GitHub APIs are the most common ones, and we'll have our APIs linked with the public APIs of the travel aggregator for online booking and real-time pricing. Now, the potential threats in production. MS system failures can lead to devastating outcomes and irreversible effects on the business of the and might lead to the closure of the business. Our AI ML based travel planner can fail either due to the software or model, or it can decay over the time due to change in its environment. Prominent model issues that can happen in our travel planner in production: training and serving skew, mismatch between the training data and input data, probability due to working on artificially constructed clean data, latency in generating predictions vary based on the volume of our input data pipeline to be served, and choice of model. Data drift if the environment changes over time due to population shift, adverse reactions, shifting travel needs, and concept drift. Distribution may stay same, but the model learning is no longer valid. Relationship shift happens and between the input and output. So finally, concluding to the assignment that we have given, the applying the AI ML backed system for our travel planner enhances efficiency and accuracy, leading to better business performance. The QuestDM process provides us a structured approach to developing the solution. Validation plan is crucial for evaluating and comparing the model's performance to existing way of working to benchmark its efficacy. Key ML system design decisions should align with business objective to maintain the ROI of the entire project. Potential issues must be proactively monitored and addressed to ensure successful implementation and sustainable solution. Thank you.